Hello, my name is Devashish Lal, and I'm a computer science master's student at the University of Southern California. And today I present to you CorgiAI, an AI-powered educational platform which aims to revolutionize learning. So the main inspiration comes from the crunch exam seasons, where you have to go through a lot of notes and stuff, and also practice questions in a limited time frame. And you don't have much sample tests available to make you feel confident about your learning, nor you can get hold of TAs very easily to get timely responses and doubt clearings. Also, information regarding some niche topics requires a lot of searching effort, and educators and content creators can't give personalized learning experiences to each student. To solve all this, I want to create a platform where custom quizzes can be generated for a specific topic. There would be a chat interface where the students can interact with the knowledge graph and get answers, personalized answers according to their strengths and weaknesses. All in all, it would be a community platform for public and private knowledge graphs, and other users can interact with them, and it all be centered around personalized content according to the user's strengths and weaknesses. So put it in short, CorgiAI is a community-based hub powered by AI to help anyone learn and practice by interacting with an ever-expanding shared knowledge graph. So let's look at the demo. So once you log into CorgiAI, you'll see the home screen where eventually you'll have a feed of personalized content. But for now, you can see the different amounts of data in the system for different topics like thermodynamics and quadratics. Now we can go to chat and start asking questions regarding specific doubts or anything that you feel fancy, like why does the curtain stick to me in the shower? The shower curtain. So currently we are running a local LLM, so the chat responses take around 10 to 15 seconds to respond. As I can see here, we have the answer, and all of the data has been imported from various Stack Exchange websites, and the LLM will try its best to cite whatever it used or found helpful in answering the question. So here you can see we have a link to the Physics Stack Exchange, and this was the actual question and answer that was used to answer our query. So along with chat, you have quizzes where you can just select whichever topic you want the quiz from. This can be multiple topics and the questions will be randomly generated from them and the number of questions. So at the end of the quiz, you'll get a quiz report showing which answers you answered correctly, which you answered wrong. And all of these questions will have a source link, which is again linking to a Stack Exchange post, which was used to generate this quiz question. So this is all there is currently available in the demo, and you can check it out at corgi.study.com. So let's look at how it all is structured around, and it's very much integrated into Azure. So you have your client, and the first thing we have is a Azure Container app, which is running our SvelteKit application, and we have automated deployments to it using GitHub Actions. And most of the backend, like the chat API, which uses Semantic Kernel, and the quiz API using the Semantic Kernel, is hosted on our local cluster. And the reason for this is because Olama requires GPU compute as well as our bigger database, which is Neo4j, takes up a lot of space. So putting all this on Azure would be costly, and we currently can't afford it on our student accounts. As well as we don't have access to the OpenAI services, so we are self-hosting our LLM and using Olama. But this provides the way we link these things together is because we don't want our self-hosted cluster to be publicly available. But so we have a Tailscale VPN integration. So the cluster or the container that's running the SvelteKit app has an HTTP proxy built into it, which uses Tailscale to access the VPN. And in the end, the actual data storage of the cleaned up data that we get from Neo4j is stored in Cosmos DB, as well as the embeddings generated from a separate Python API is stored in the Azure AI search services. Eventually, we want to add the capabilities of uploading files and documents and integrate AI document service from Azure as well. And the way the APIs have been architectured is the LLM endpoints can be changed to like Azure AI or OpenAI services with just a configuration change. Nothing else is required. And all that comes from the power of semantic kernel, and which is what I've really liked working with semantic kernel. And through that, and I tried giving back and contributing back to the semantic kernel project. So the Olama AI connector that the current Corgi project is using, I've raised a PR for that. So what's next for Corgi AI now that we have quizzes and chat working? So knowledge graphs is another core feature or the main selling point of Corgi AI. And knowledge graphs will allow any user to create public, private, or invite-only graphs. They'll have full data governance of the data that they put into the graph, along with a robust ingestion system, which will eventually use the Azure AI document service to import a wide variety of data formats. And you can not just create your own graphs, you can interact with other graphs. An example of this would be like a university professor creates a graph for a particular course, and his students can interact with that graph, essentially getting doubt clearance from the professor's knowledge. And since it will be integrated with the user's analytics systems, the doubt clearing will be personalized to that user's strength and weaknesses. At the graph level, the creator of the graph will also have output monitoring, and it can provide feedback as part of comments to all the output the LLMs using that graph is generating, like maybe quizzes or some answers that are not up to the mark, so you can add corrective comments, which will be further utilized in the future generations. And also, you'll have graph level analytics, which I think is very useful for educators and professors to see how, if they could, on a level, understand how effectively their students are absorbing the knowledge by aggregating their strengths and weaknesses. So all this requires some technical challenges. One is integrating Azure Document Services and integrating an analytics framework and try to build models around all the data that's being collected. And finally, we want to go beyond embeddings and utilize graph database by natively representing knowledge in them. And I think that would allow us to give more richer output and feedback. So that's all we have for CorgiAI today, and be sure to check it out at corgi.study. And I hope you liked it, and we're going to be working on it further. Thank you.